Danger! I'll be handling corrosive acids and doing reactions that produce deadly fumes in this video. I'll be working inside a fume hood to vent the deadly gases away from me. Doing these reactions in an enclosed area or without proper safety equipment could cause serious injury or death. Hello YouTube, welcome back to my channel. I'm Sri Tips. Today what I'm going to do is process some of these melt drop bars from eBay. I've heard them referred to also as different computer parts melted in the eBay listing. A viewer of mine, a subscriber, his name is Chris, sent these to me. I was looking to buy some for myself, and he just happened to email me at that very time and said he had some and that he would send them. So thank you, Chris, up in Massachusetts. I appreciate the metal to work with. So what we're going to do is we're going to process these and see if we can get some gold from them. We're going to do that right now. Okay, in order to find these bars on eBay, I went to the eBay website, typed in computer scrap, different computer parts, and up came these melt drop bars that I'll be working with today. Okay, in order to find out what some of these bars actually sold for, I go up here to the Advanced button, up in the upper right of the screen there. I click on Sold Listings, and then press Search. And what it'll do, it'll pull up some of these bars and what they sold for. Here you got one for $117.50. There's one that went for 1 cent, 25 cents. There's one, $11.50, $57, $17.44, $13.50. So people are paying money for these bars. And what I want to do is try to find out exactly how much gold we can expect to recover from some of these melt drop bars from eBay. I've stacked these melt drop bars on my scale there, and I've got 1,966 grams. This scale only goes up to 2,000 grams, and so I've got 4 little pieces left down here, and they're probably going to be in the neighborhood of 200 to 300 grams total, these little pieces. So I got probably about 2,200, 2,300 grams worth of these melt drop bars that Chris sent to me. Whenever I have an unknown sample like this that I'm not certain how much gold it contains, I'm not going to go all in and do the entire batch. I've selected 3 bars here that weigh 211 grams. And so what we're going to do is we're going to put these in a melt dish and melt these up and just do a small quantity first before I commit to doing the entire group. Now we're going to go ahead and melt these with a MAP gas torch. The MAP gas torch was melting the metal, but I added my acetylene torch to speed things up. Next, I stirred the molten metal with a graphite rod to ensure that everything was properly alloyed. Once I got everything molten, I killed the MAP gas torch, and then I picked the crucible up and carefully pour the molten metal into a metal container of tap water. If you notice down in the bottom of that container that has the water in it there, the metal stays red hot for a couple seconds before it cools off completely. That's why it's important to use a metal container here. pouring the metal into this water forms these granules, increasing the surface area of the metal so that the acids can attack it better in the next step. Alright, I take the granules, I pour off the tap water out of that metal container. Then we transfer the granules into a 1 liter beaker here. And then I use some distilled water to rinse off the granules, just in case there's any silver in here. In this next sequence, I add about 200 milliliters of distilled water. And then I'm going to pour in some concentrated nitric acid here. And we'll start dissolving out any of the base metals that are in that metal. If there's any gold in there, the nitric acid will not dissolve the gold. It will get left behind as a black or brown powder. This section of footage is speeded up 2 times. I suspect there may be some brass in there by the way this is reacting. Brass is an alloy of copper and zinc. After 3 or 4 minutes, the reaction calmed down. I tried to grab it here and the beaker was too hot for me to handle, so I grabbed it with some tongs. Set it up on the heat there. We're going to start heating the solution, see if we can get everything to dissolve. I just set this on the heat. I just got done adding the acid. The time right now is 1:20 p.m. We'll just let this go and keep adding dilute nitric acid to it until we get all the base metals dissolved out of the metal. This only took about 15 minutes and all the fumes are gone already. So what I'm going to do is I'm going to pour this first nitric treatment off into this big beaker here. And then we'll add some more nitric acid and keep doing this until we get all the base metals dissolved off. What I'm going to do now is set this back up here. Put a little bit more distilled water in it. This time I'm not going to add so much nitric acid there, just a little bit because of the vigorous reaction that I got when I put too much nitric in at once. Here we go, second hot dilute nitric treatment. That's probably about 30 or 40 milliliters of hot dilute nitric acid. It's just before 4 p.m. I've been working on this now for about 2.5 hours. I've got about 750 milliliters of liquid down here in this big beaker. Go ahead and pour this off now. Take a look at what our material looks like in this beaker. So far it's holding together okay. Here's what we got. I'm going to rinse this off. We're going to add a little bit more hot dilute nitric and keep going with this. I don't know if you can see it on camera or not, but the metal looks like has the color purple to it. I'm going to add some distilled water here. Put it back on the heat. And then I'm going to add a little bit more nitric acid. I've been through about 300 milliliters of nitric acid so far. I'm going to go ahead and pour some in here and keep going with this. wanted to get a shot in the bottom of this large beaker here. I've got some red colored material forming on the inside of the beaker. I'm thinking that's going to be some kind of copper compound. It's 5 p.m. right now. I've been adding droppers full of nitric acid here. And I'm going to keep doing that until I don't get any more reaction, no more fume production. Let's see if we can get the rest of the base metals dissolved out and see how much gold we can get from this, this scrap. It's exactly 20 minutes past 6. I'm going to dump this off, and we're going to get a look at what our material looks like in here. I've probably had about 400 milliliters of concentrated nitric acid on this material. Give it a quick rinse with some distilled water here. Alright, here's our material. It's still pieces of metal. And looks like I got a ways to go with more nitric acid treatments to get this fully dissolved so I can see how much gold I can extract out of it. It's been 5 hours now. I'm going to keep hitting the metal with dilute nitric here. See if we can get the rest of this stuff dissolved out of here. Put it up on the heat now. And keep dissolving. This is about 4.5 minutes of footage, speeded up 16 times. And you'll notice that all of the material goes into solution. Alright, it's been about 5 minutes since I added that last dose of concentrated nitric. And I just want to show you here what I got. I've got everything in solution. And there is zero, nothing, no residue at all left in this solution. So what this tells me is what I suspected all along. These bars have no gold in them. Zero. I don't even... Alright, I'm going to try to run this solution through a filter here just to verify that we don't have any residual material in this solution. So I'm going to pour this through a filter paper. Let me add it to this beaker here, and then I'll just filter the whole thing. As you can see, there's absolutely zero material in the bottom of that beaker. Well, I must say, this is looking like it's going to be the worst yield of any experiment that I've ever done, because I think it's going to be a big fat zero. Just want to verify that I don't have any metals in solution here. I'm going to do a stannous test. As you can see, it's just a blue stain. I've got zero gold in solution, nothing. No precious metals in solution. Alright, I'm down to the bottom of the beaker. And I get down here, and I didn't think there was going to be anything at all in here. But I do see a couple of pieces of solid material in the back there. Alright, after getting rid of all the copper solution. I've got a little bit of material left down here. I don't think it's gold. It's got too much of a reddish appearance. I think it's the copper that was clinging to the inside of the beaker. But what I'm going to do, add some hydrochloric acid here. Just enough to cover the bottom of the dish or the beaker. And then I got a little bit of nitric acid in a pipette here, about 3 milliliters. I'm going to put this in and see if we get any kind of reaction that would indicate that this might be gold here. Alright, we've got the aqua regia on that little bit of solid pieces in here. I'm going to stick this up on the heat now. And we'll see if we can get this to dissolve. And then do a test with stannous chloride to see if that's gold. I was not counting on a result here. I was counting on a 0 yield. But this is looking kind of peculiar here. I'm not sure what I've got. We'll get this to dissolve here in a couple minutes, and then we'll do a stannous test, see if we got gold in solution. Okay, everything went into solution there in less than a couple of minutes. Take this down off the heat now, and we'll see what kind of metals we have in solution now. Okay, here we go. Moment of truth. See if we got some gold in solution. I'll eat my hat if this turns out to be gold. I was expecting a 0 result here. Let's see what we got. I got nothing. No reaction. And what that tells me is, I don't know, man. No precious metals in solution there. This is my standard testing solution, 1 gram per liter of gold. We'll put a little bit on this filter paper right here, and we're going to test my testing solution to make sure it's good. And as you can see, the stannous chloride testing solution is good. Alright, I've got some ammonium thiocyanate here, and what I've done is added a few crystals to this spot plate right here. And what I'm going to do is test for the presence of iron. Iron will look just like gold in solution sometimes. So we're going to see if we got iron in solution from this yellow liquid that's in this beaker. If it's iron, it's going to turn bright red. And there you go, it's iron. There is a little bit of residue in this filter. And so I'm going to rinse as much of the blue liquid off the filter as I can. And we'll throw this in this big beaker over here, add a little bit more acids, and see if any of this residual material in this filter is gold. I'm going to add a little bit more hydrochloric to the beaker here. Now we'll take our filter and put that in here. Then I've got some nitric acid in this pipette, about 3 milliliters. Add that in. Now we'll cover this up, put it back up on the heat, and see if we can get a little bit of gold out of this filter. Alright, this has been on cooking now for about 5 minutes. We'll pull this down, we'll get a stannous test on it. Alright, let's reach down in here. Some of the solution on our filter paper. And I'm going to put some stannous chloride testing solution on here and see what kind of result we get. And I do see a very, very slight purple stain there. Very slight. Here I'm filtering the solids out of that solution so I can try to precipitate any gold that might be in solution. Got all the solution filtered out now. Get this out of the way. Transfer our solution into this beaker. And then what we'll do is add some sodium metabisulfite, see if we can precipitate out some gold out of this solution. One spoon ought to do it. Okay, we're getting a little bit of brown forming in the solution there. This is probably going to take a while to settle out if I get anything. It's probably going to be less than 1/10 of a gram of gold here. This has been settling now for about a half an hour. And as you can see, there's nothing visible that's settled out. I'm going to make a judgment call here based on my 9 years of refining experience. There's going to be less than 1/10 of a gram in this solution. It's not worth trying to gather it up into filter paper and melt it. I'll just add this to my stock pot. This will conclude the melt drop bar refining video from the melt drop bars on eBay. What I got here was I used 211 grams for my batch, and that yielded approximately 1/10 of 1 gram. Alright, so I started out with 2,300 grams total of the melt drop bars. Divide that by the 211 gram batch that I did, and I get 10.9 batches of 211 grams. I multiply 10.9 batches times my yield, which was 0.01 grams, and I get an effective yield for the entire group here of 0.109 grams, a little under 2/10 of 1 gram. And notice down here I used 500 milliliters of concentrated nitric acid for my 211 gram batch. So the bottom line here is the yield is pretty much very close to 0. It was no use trying to collect the little bit of gold that was in that solution and put it in a filter paper and try to melt it. It would be a little bitty speck, no bigger than the head of a pin. So I called the video, I called it right then and there, and we're going to stop right now. I'm not going to process these because this will take a bunch of nitric acid and yield no gold. So for those who are thinking about going out and purchasing these melt drop bars on eBay, I would discourage you from doing that. I give it my best shot here, and I got nearly 0 gold from these melt drop bars. Okay, that will conclude the video. Thanks for watching.